welcome to this class. This will be really exciting. I got involved because basically back when I was a student and working on dissertation topics, I was kind of aware of how software engineering was taught, and it just struck me that it was such a terrible match to the classroom. At the time, it was armies of IBM programmers and there's elaborate mechanisms in it. Just impossible to do in the classroom, so you'd lecture about it, and then and the students would completely ignore everything you said and do the programming the way they'd always done it in the past. And it just, it was a really important thing that faculty talk about software engineering, but it was really hard to teach in the classroom. And so it was exciting, these ideas that came out of actually a research project at Berkeley where we wanted to get undergraduates involved with building the next great internet service, and we learned about Ruby on Rails, so we started teaching it, it's completely transformed. Is that the ideas today of modern software techniques, Agile and stuff like this, is a perfect match to the classroom. And so Armando showed this could work, and a suggestion to do it in 169, so we got involved and made this blood oath to write a book together, and this crazy Stanford thing has come along. So it's really going to be an adventure this semester. But kind of from my perspective, from this hardware background, the way we started off talking about, how are we going to talk about what's going on and why, is we thought we'd start off by saying why it's different from engineering hardware. So in particular, one way it's different is there's no disasters in hardware. So you see this list here. How many of you have heard of the Ariane 5, the Etheric thing, Mars, all these things? Yes, these are kind of cliches. But this one is so much fun that this one's worth seeing. What it actually was, for those who are interested, is they actually had run this on the Ariane 4 rocket, right? And it worked. The Ariane 5 had a longer distance to cover. In the middle of the routine, they kept, because this is done, memory is precious, they stored things as 16-bit numbers. So they stored it as a 16-bit number, and then when they had to do the floating point, they convert it to floating point, and they calculate, and they store it back in a 16-bit number. With the longer distance flight, it didn't fit in the 16-bit number. So that was a arithmetic overflow side effect. We'll talk about, I think we'll talk about now about the importance of testing and system-level testing versus, but these other ones are there. So software is just famous for these disasters, billions of dollars. That one ended up in losing $360 million in satellites. So why is this happening, right? Why does this happen? And we think it has to do with basically the fundamental nature of the media itself. So think of it, there's different cultures around hardware and software, and we think it has to do with basically the cost of a field upgrade. Basically, if you have to upgrade all the computers in the field and the person, there's a flaw in the Intel microprocessor, we're going to have to upgrade all of the 300 million PCs. That would cost infinite money, right? So you just can't do that. So as a side effect, hardware really has to be, when you ship it, it really has to work, right? And that's the culture around hardware. And if you get hardware and it doesn't work because you know it's supposed to work, then you think there's some manufacturing flaw in that piece of hardware, so you send it back, right? And if you're a company and all your products get sent back, then you lose money. What about software? Field upgrade is approximately zero. It's not actually zero. Right? You have to set it for infrastructure and distribute the upgrades, but it's close to zero. So if it's okay to upgrade in the field, then why do we have to make it work the first time, right? So the expectation is with software, and then not only how well does it have to work in the beginning versus hardware, but also the culture has grown up is you expect the software to get better over time. So that means get rid of initial bugs, but also means I expect enhancements over time. And that's the culture that's grown up around software. And if you get software, you get the first version of software, there's bugs in it, you're not surprised. That's okay. I'll just wait for the next upgrade. I'll go check right now and see if there's an upgrade, and that's kind of the culture that's grown up around it. So because the differences of the two media, the cost of the field upgrade, completely different cultures have grown up around software and hardware. And the other thing that's interesting about this, because software gets better over time, when you ship a microprocessor and you're very excited about it, but the day you ship it, it's starting to get less valuable, right? And it decays. And after a few years, they're going to throw them all away. This thing you design, you can go find it in the junkyard within 5 years. software can last forever. And we found in the book, there's an example of a program that's at least 50 years old but still being used today. So the software that you guys are writing now plausibly could be long when you're past my age, that software could be out there. So it's got this ability to do almost immortality, which is kind of a remarkable difference. So there's this phrase called legacy code, which I'm sure you're all heard of, and it is referring to the long-lasting nature of software. But what that means is it's something, well, if it's this program that's around for 50 years, it must be doing something useful, right? Other people would stop using it and it would go away. But what the legacy has this negative connotation, and that it's kind of antiquated in some way. It's using old-fashioned technology. So you kind of besmirch the name of the developers. Oh, that's just legacy code. That it's still there, yeah, but it's really old-fashioned technology. And so this has indicated some about the kind of popularity of legacy code, is that we spend a lot of the time, cost in software maintenance of adding legacy code. A lot of the software costs go into that as opposed to just fixing bugs. So we had to come up with a contrast. We don't want you writing legacy code. We'd like you to write code that lasts a long time, but we don't want people making fun of your code calling legacy. So there's another phrase called beautiful code, and that's what we want you to build, beautiful code. And it's like legacy code. It meets customers' needs, but it's easy to evolve. And evolution is a key to long-lasting software, and we hope that you're going to learn to use that. So what I wanted to say about legacy code, one more thing, is when Armando and I, nobody teaches about legacy code. We can't find it in the textbooks. We looked at other course descriptions. Nobody teaches about it. So one of the things that we did when we were trying to figure out, we're going to redo how to do software education in this new model, we went to our friends in industry at lots of leading companies. So what did they want? And the first 3 people we talked to said, you're all going to have to deal with legacy code. And we fought back. We tried to argue with them. You know, we asked for feedback. And then the 5th and 6th and 7th people we talked to all said the same thing. The number one thing at every company, this is Google and Microsoft, Amazon, you know, all these companies, you need to deal with poorly documented code. That's what you need to teach them. They had their second choice was different for all the companies. The first choice was all the same. So we thought, oh God. And we tried not to do it, but we realized if that's the feedback, we got to do that. So new to this version of the course, never been done before, not for the online course, but in the second half, we're going to have a legacy code assignment. So we'll be anxious to see how this turns out. But absolutely in terms, we believe if when you go out for job interviews, they don't care that much about the grades, they want to know what you know, and you go out there and they say, well, tell me about your software development experience. And you say, yeah, I'm familiar, I've done legacy code enhancements, their eyes will get big, is what we will do. So what's an epic failure? Well, beautiful code is not an epic failure. Unexpectedly short-lived code, that's pretty bad. Legacy code is actually successful, right? It is continuing to meet the customer's needs. So people make a lot of money with legacy code, so it's hard to say it's an epic failure. But unexpectedly short-lived code. I mean, you put all this energy into it, you ship it, and within 3 months, nobody's using it anymore. That's the epic failure. So legacy code isn't wonderful, but the idea is what we want to do is for you to be able to, you know, avoid doing it. It's not as successful as beautiful code.